What's up, everybody? Today we have an amazing problem for you guys. So let's quickly go ahead and read the problem statement, guys. So before we get into it, guys, I'm LeetCoder, and on this channel we do a lot of data structure algorithm questions, right? Specifically LeetCode questions, and we solve them and we get solutions to them, right? So if you're interested in that, consider subscribing to the channel, guys, right? So the thing's called all path from source to target. So it says, given a directed acyclic graph, right? Okay, that's very interesting. I'm telling us, guy, right? Directed, which means the edges are one directional, right? Acyclic, no cycles, nice. And it says of n nodes, right, labeled from 0 to n minus 1, right? So the nodes are labeled from 0 to n minus 1, right? So to say n is like 5, right? I mean, the nodes are labeled from 0 to 4, right? That's what they're saying here, guys, right? So it says return them in any order, right? So it says to find all the possible path, right? Starting from 0 to node n minus 1, right? So a very interesting thing. They're giving us a source node, right? And they're giving us a destination node, okay? It says return the paths in any order, right? So the order does not matter. Just return all the paths starting from the source node, which is 0, to the destination node of n minus 1, right? So very, very simple. It says the graph is given as follows, right? Graph of I is a list of all the nodes you can visit from node I, right? So, okay, very convenient. So it says, i.e. there's a directed edge from node I to node ij, right? So interesting, right? So for every index, right, which represents a node in the graph 2D thing, right? For every index that array is gonna hold all of the neighbors that that node is pointing to, right? That's exactly what they're saying. Okay, so for node 0, right, this is the first index, right, which is the index 0. So for node 0, right, this node, those are the neighbors that it's pointing to, right, because the edges are directional. So I mean that node 0 is pointing to those nodes, right? And if for node 1 is pointing to only 3, right? As you can visually see, it makes sense, right? And then node 2 is pointing to 3, and then 3 is not pointing to nobody, right? It's an empty list, right? So yeah, so now our job, guys, what they're asking us to do, right? They're asking us to find all the path, right, to all the paths to the destination node of 3, right? Starting from the source node, which is the source node is 0, right? So find all the path that leads to a destination of n minus 1, which is in this case 3, right? The last number, right? So yeah, so for this example, we see that we have the paths that can leads to 3, right? 0, 1, 3. We're good here. We got 0, 2, 3. And we end up being here, guys, right? So this is how we end up with those two paths here, guys, right? So this one is interesting. You can see there's a lot of different ways to get from 0 to 4, right? We could go from 0 to 4, right, which we take into account here. We could go from 0, 3, 4, which is here as well, right? We go from 0, 1, 3, and then 4, right? And which is good right there. And we go from 0, 1, 2, 3, 4, right? Which is another one right there, guys, right? And then we could also do, I think they have 0, 1, and all right, we almost missed that one, right? 0, 1, 4, which is right there. Okay, so this is how they get all the path to 4, right? So how can we solve this particular problem, guys, right? We could solve it many different ways, right? So to us, how we plan on attacking this problem, right? So so what kind of thing that we need? So we know we need to do some kind of traversal, right? We know that we need to, find a way to get to destination. So we're kind of already comfortable with a lot of the traversals already, right? We went over on this channel about breadth first search. We went on this channel depth first search as well, right? So we've went through the different controversials. We know the pros and cons and which one to choose and particular scenarios, right? We went over that. So if you guys haven't seen that, something will pop up, right? So for this scenario, right, we just need to find all the paths leading to that, right? So I think the depth first search is definitely the algorithm of choice, guys, right? As it is efficient for this kind of solution, right? So we're going to go with the depth first search, right? Because we could explore a path all the way through, and as soon as we get to that path, we're good. We account for that path and we're good, guys, right? So this is exactly what we're going to do into depth first search. So how the depth first search is going to work, guys, right? We're going to pretty much, as we're traversing the graph, right, we'll be constructing the path that lead the path that leads to a we'll be constructing the path, right, that leads to us the destination node, right? So as we're traversing, so let's say we start from node 0, right? Because we always start from node 0, right? We start constructing the path. We add the every number that's included in the current traversal, right? We account for it by putting in some kind of a list, right? So a temporary list or a list, right? To represent the current path that's on. So right now we put 0 in there. Let's say we visit 2. We add 2 to the list, right? And then a 2 visit its neighbors, right? Which is 3, right? There's only one neighbor for 2, right? And it visits 3. We know we arrived to that destination, right? We add 3 to it, right? And then we get to our base case, right? Which is the node 3, right? And then we are good. We put it into our output results, right? And then we backtrack, right? 2 has nothing, nobody else to visit, right? Backtrack again, right? And then we get to 0, and then 0 now visits 1, right? Because, it's also pointing to 1, right? It visits 1, right? So now once we're at 0, right? We backtrack, right? Only 0 is in the list, right? In the path now, right? So we visit 1, and then we add 1 to the path. So now the path includes 0 and 1, right? I want to stress that when we're backtracking, we're removing the node from the list, right? So we don't account for it, right? That's what I'm doing, right? So after we add 1, right? We add 1 to it. So now the path now includes 0 and 1, right? So now the list that we're constructing, which represents the current path that we're on, right, is going to include only 0 and 1 at this time, right? And then now 1 is going to visit its neighbor, right? And then it's going to visit 3, and it's going to add 3 to it, right? We get to our base case, add it to our output, right? So it's the same thing we're going to do here, guys, right? So the general goal, right, is to use a list, right, to help us in knowing the current nodes that are on the current path that we're on, right? So we add the node that are the current path into a list, right? And then once we are not on that node anymore, right, we backtrack, which will remove that node from the 1, right? So after we visit 3, there's nobody else to visit, right? We backtrack to 1, right? And then now the list is only, you know what I'm saying? And then we backtrack again. There's nobody else to visit because 0 has visited all of its neighbors. Then we're good. We return from our calls, right? So that's kind of the general gist of it, right? So let's quickly go ahead with the implementation, guys. Hopefully you guys were able to follow the thought process, right? And hopefully the code makes a lot more sense to you guys, right? So let's quickly go ahead, guys, right? So we're gonna have a DFS function, right? So, right? And then we're gonna need to have an output result, guys, right? So this is what's gonna hold all of the different paths, right, guys? Right? All of the different paths for all the path that leads to the destination node, right? Okay. And then we're gonna pass in the graph, right? Okay. We're also gonna need to pass in, guys, right? A temporary list, right? Of the list that's gonna help us in constructing the path, right? Okay. Let me see if that works. Arrays as list. And then we put 0, right? So 0 is the starting node, right, that we have. And then we're also going to pass in, guys, we're going to need to pass in the paths, right? Which is what's going to hold all of the paths, right? Okay. And also we're going to pass in the current node that we're on, which is node 0. That's always the initial node, guys. And after we do our DFS, right, we found all the paths that leads to the destination node. We can return our path to the caller, guys, right? So let's quickly implement the RDFS function, right? So now we'll turn anything, we'll just do DFS, right? Okay, we're gonna pass in the graph, right? We're also gonna pass in the path, right? The current path that we're building. See, what's gonna help us in building the paths, right? Is how we're gonna represent it as some kind of a list so that when we get to a destination, we could easily add it to our output result, right? That's kind of the reasoning behind that. And then we have the paths, which holds all of the paths, right? Okay. I'm seeing I got enough space. You guys see everything, right? Okay. And then we also need to know the current node that we're on, right? So that's why we have here the current node, okay? So now what we're gonna do, guys, it's gonna be once we get to the destination node, right? So once the node that we're on, right, equals to a graph, right, that length -1, right, which represents the last node, right, which is equals n-1, right? So we'll be saying that to add paths, right? That add new array list, right? We're gonna do a deep copy. Okay, and then we're gonna pass in the path, right? Which is what we use to represent the path that we're building. I'm stressing it, guys. Make sure you guys understand. Okay. And okay, let's say that's not the last node, right? So now we visit the neighbors, right? Because we're trying to find a path that leads to that, right? So what we're gonna do, int neighbor, right? And we have access to our neighbors by what, guys? By the graph, the data structure that's given to us, right? And then we reference the node that's in that. We reference the index, right? So for node 0, right, we reference the first array, right? So make sure you guys understand that. Okay. So what we're gonna do, we're gonna construct our path. So we're gonna be adding, we'll be adding that neighbor to the current path, right? To now we're gonna start exploring on that path, right? Since we're including the neighbor now, right? So we're gonna do DFS, and we're gonna pretty much do graph. We're gonna pass in the path, right? We're gonna pass in the paths, and then the neighbor now will be the current node, right? Just doing the current exploration, and then what we're gonna do after we get out of the exploration, right? We're gonna remove that node now, right? So since it not be accounted for now, and then we're gonna visit another neighbor. Right? So you see what this was the case where we were at 0 from 2, backtrack to 0, right? And now we remove 2 from it, and then we start exploring with 1, right? Okay. So path that size, right, -1. Right? So this is the last node that was on there. We just remove it. Okay. All right, it looks pretty solid, guys, right? I think we're in good shape. Let me see. All right, looks like we passed the small test case. So let's just quick recap, right? So we have the output list that's going to hold all of the different paths that leads to that destination, right? And then we said we'll be choosing the DFS algorithm, right, to find all of the paths that leads to the destination, right, of n-1, right, starting from node 0, right? And then we put 0 as the first node of the current path that we're building, because 0 has to be included because we need to start from 0, right? And then we start exploring all of our neighbors, right? And until we get to the last node, right, we add that node to our path data structure, the path that holds all of the paths, right? And then we add it that we do a deep copy so that because the path is being passed by reference, right? So yeah, because this will be changing. So we do a deep copy of that, right? And then we visit all of our neighbors, for a particular node, right? And then we choose that node, and then we explore that node, and then we unchoose the node right there, right? So we remove the node, right? So let's press submit, guys. See if we pass all the test cases. Awesome, guys. We were able to pass all the test cases, guys. So I want to thank you guys for taking the time, guys, to kind of watch this video, guys. If you guys found value, make sure to give me a like. If you guys are new here, make sure to subscribe, because I'll be doing a lot of other videos just like this one. So thank you guys for watching, and I'll see you guys in the next video.